we have another TV. In this case, it's a Grundig. The problem with this TV is that when I plug it in, absolutely nothing happens. There is a main power switch on the side of the TV, it does absolutely nothing, and there is a soft power switch on the left of the TV, and it also does absolutely nothing. So we have a no power here. So let's take the TV apart. So we have mains power going here to the main switch, and from the switch to the power supply, which oddly enough has a replaceable fuse. So first let's take a look at the fuse. And the fuse is blown. The fuse is blown, as you can see, and it's a 2 amp fuse. Okay, and we can see a nice burn mark here. So in this case we definitely have a power supply problem. What I'm going to do is I'm gonna take the power supply out and take it to the bench where all my tools are to see what happened and if we can fix it. Okay, so here's the power supply. We have a easily replaceable fuse, and there is a burn mark right here. We are going to have to investigate what blew up. Okay, so here's the power supply, and first let's have a look what blew up. Give me the light. So this capacitor right here does not look exploded or anything. This diode looks fine, it wouldn't explode right there. So what happened here then? It might have been a whisker or a bug of some sorts. This NTC right here looks kind of burnt, but that's just the glue, I think. So let's test for shorts in these surrounding parts and see if we find anything. So short test. We test the diode, positive to negative. The diode is fine. The transistor is not shorted. The other transistor not shorted. The capacitor is not shorted. And one thing I just noticed now is that this black spot on this NTC is not because the NTC exploded, but as you can see, give me the light, as you might be able to see right here, this focus, this resistor right here is exploded. So let's try to see what that resistor is for. You will always have a resistor in series with the main transformer, and that's the current sensing resistor. Okay, so this would appear to be a 5-band resistor. We have brown, red, red, silver, gold, and that would be a 1.2 ohm resistor. So let me see if I can find anything similar. Okay, so I found this resistor right here. It's a brown, black, gold, gold, which is a 1 ohm resistor instead of 1.22, but until I get the real value I need, I think this one should do fine. So let's take it out of its prison. Okay, so I replaced this resistor with this one. I soldered it from the bottom because its legs are a bit shorter and they couldn't reach. And when you look at it from this side, this resistor is not much taller than all of these pins, but so it should be okay. And that should be fine, at least for now, till I find. I will replace it with the correct value when I find it, so I know which one was supposed to be there. Now let's try to turn the power supply on and see whether or not it explodes. Okay, we have enable and PWM. We have first and second are enable and PWM, that's for the backlight, and all the others are ground and 12 volts. So this power supply should be always active. Nothing has exploded, but I hear clicking. Do we have 12 volts on the output? We do have 12 volts. It's probably clicking because it doesn't have anything on the output. So let's try to turn it off. Let me see if I can get some wires. Connect the wire. And it's no longer clicking. So the reason it is clicking is because there is no load. It's failing to regulate and it's running in burst mode. So what that is let me grab a piece of paper. Power supply stops the PWM because it cannot lower the duty cycle, and it turns off until the voltage drops below 12.5 volts when it turns on again. So you have that sort of oscillation, and that's why you hear a clicking noises when this power supply is running with no load. That's called a burst mode. So let's put the power supply back into the TV. Fucking hell! Okay, so let's put the power supply back into the TV and let's see whether or not the TV works. Fucking shit. Okay, we're back on the TV. Now we're going to put this evil power supply that bit me earlier back into its place. Here are some AliExpress special fuses. I wouldn't actually recommend you to buy these because they don't blow when they should. I mean, you can push like 5 amps through a 2 amp fuse and it won't blow up. So they're good enough to protect against a short circuit, but not really against overload. So let's see. I'm going to plug it into my current limit. I'll give it 8 amps and let's see what happens. Oh. So the short circuit appeared between this pin right here and this pin right here. So this is where we had a short circuit. This right here is the diode, this pin and this pin, and these two pins are the the primary coil of the main transformer. Let's trace this circuit. The positive from the main capacitors go through this small resistor I replaced to the one pin of the main transformer, and then from the other transformer went into the diode, which went through to these pins, which are the outputs of the two switching transistors, which are this thing right here and this thing right here, and they switched into this line right here, which went through this resistor into the negative. And that's where our short circuit appeared. And now checking components on that line, I noticed that this says R130, that's 13 ohm resistor, but when I measure across it, I get a direct short circuit. Now, I don't think a resistor failed short circuit, but right next to this resistor is a small diode, which, if we go into diode test, measures a direct short circuit. So the power supply probably worked because this diode acted like the current sensing resistor, but as soon as we put any load on the power supply, I mean higher load like the backlight of the TV, the power supply just fell over. That little diode is still in a short circuit. So we found our problem. Oh, and plot twist, this is not a diode, this is a zener diode. It was probably clamping the voltage across this resistor in case it got too high to prevent damage to this IC. So without this diode, we probably would have to replace this chip right here. So where the heck do I find a zener diode now? Ah, thankfully I had bought some zener diodes for a project, and coincidentally I have a 5.1 volt zener diodes. Let me just see which ones are they. 16 5V1, yeah, this is the one we were looking for. It says on it, let me take one out. Though this is a symbol of a normal diode, not a zener diode, which is weird. Why would they would I don't think a big company like that would use the wrong symbol. But oh well. So let's see, under the light it says 5V1 and the old one says 5V1 too. So I guess we just have to put the diode in. And solder it in. This diode also probably saved this current sensing resistor, which is good. I mean, I never seen a zener diode being used like this, but I like it. Okay, so let's try to power on the power supply and see if it makes any weird noises. And let's get these out of here. It works, I think. No strange sounds. I don't know, 1000 volts. 330 volts on the input, and on the output we have 13.3 volts. So it's probably still doing the ringing thing I mentioned earlier, but this time it's doing it quietly because it actually knows what the amount of current flowing through the circuit, which it didn't do earlier, and it just was kicking the power into the transformer, and that's why we're hearing a clicking noise. The voltage is still like 13.3 volts instead of 12, but what can you do? So let's put the thing back into the TV and see what happens. Okay, I'm going to give it full power right away because I think it will be fine this time. Of course I did.
You're a fucking idiot.
We have picture. Yeah, we have picture and the display is fine. That's good. We fixed this TV. So let's put it all together now and test it out.
That means that if we go back to the switching transistor part of the circuit,
And there we go. We have a functional TV.
feedback from the 12-volt output,
See ya.
which tells the transistor to increase the